Okay, hey everyone. I want to do a quick comparison of image quality between a couple of Nikon wide-angle zoom lenses. These aren't the real most popular wide-angle zoom lenses for astrophotography, but I had them laying around, and I actually have used these, especially if you're in a pinch and you're trying to pick which lens to include in your bag, you're traveling. It's nice to know what they're capable of. So I just want to make this video to help some people out. Just going to strictly go over some image quality between the Nikon 17 to 35 f2.8 and the Nikon 16 to 35 VR f4. Both are AFS lenses. The 17 to 35 is much older, still a great lens. So I'm going to just dive into coma and sharpness and that sort of thing. You can make your own assumptions from there. So let's dive right into it. We're showing here the 17 to 35 on the left. They'll always be on the left, 17 to 35 on the left, and 16 to 35 on the right. So I'll always have the 16 to 35 on the right and the 17 to 35 on the left. So zoomed out, yep, there's coma on the 70 to 35. Surprise. I mean, kind of would have figured that. To me, though, I've still used this lens because that's pretty easy to crop out. You could maybe crop it out from here and all of that goes away, that ugly coma. So I'm going to zoom in here. Let's take a closer look. Now, keep in mind, we are comparing the 17 to 35 at f2.8 to the 16 to 35 at f4. So not totally fair, but I guess, it is what it is. I'll compare them both in a little bit here at f4. So at f2.8, I don't like this. I would crop that out. But it's not bad for being such an old lens. Again, these images were taken at 20 seconds, 17 millimeters for the 17 to 35, 20 seconds, and then 20 seconds as well for the 16 to 35. So there might be some slight star trailing here. I wouldn't blame that on the lens. I wouldn't think so, but I mean, looking here, it doesn't look like there's much star trailing in the center of the frame. So that might be more of just the lens aberrations we're seeing. So I think this is great for being such an old lens and having a plastic element in it. I think we're doing pretty good here. I actually really like this 17 to 35. It has a lot of uses. And it being a constant aperture and a smaller lens that takes 77 millimeter filters, it's awesome. For the 16 to 35 takes 77 millimeter filters as well. So I like that, but f4 isn't the greatest for astrophotography or Milky Way photography. So there's kind of pros and cons, but having the VR is nice, especially if you're in, a cathedral or, somewhere you need a wide angle and you can't have a tripod and you got the VR. So there's uses for that for sure. I really like the 17 to 35 though, for having the brighter aperture. So you can make your own assumption and kind of take a look at these, this image here and make your own judgments. I'm just here to just share what I found between these two on a nice, clear, crisp night. I wouldn't get too hung up. This one's showing a little more coma on this light here. It was a little breezy, so that tree might have moved a little, but I am going to say that that's coma right there. So anyway, let's stop ripping on the 17 to 35 coma, and I'm going to pull up the f4 image, and let's see how it does now. 17 to 35 at f4 compared to the 16 to 35. And for all of you wondering, why is he comparing a 16 to 35 f4 for astrophotography? I use this lens actually a lot on my Skyguider Pro. It's great if you are in a situation where you want to bring like a tracker or a Skyguider Pro or anything like that, and you're going to be shooting other things where you need the VR and you don't have all the room for all these lenses. That 16 to 35 is great. You put it on this Skyguider Pro and you stop it down a little bit. It's a great great lens. So f4 is not a deal breaker at all, especially with cameras today with high ISO performance. Not a deal breaker at all. Okay, so extreme corners, bad, fuzzy. But then we get right about here, and the 17 to 35 is actually looking pretty good. In fact, I'd say comparing this star to this star, that the 17 to 35 is sharper. These are both manually focused. They were manually focused on Jupiter, so it was pretty easy to get a nice round star. And then I also did another series where I manually focused on just another bright star that I could find. So these are the best of the batch. So I'm pretty confident that these are the best, at least for the copies of the lenses that I have. This is the best that I could get. So it looks like the 17 to 35 starts looking better actually at f4 there. If we go towards the middle of the frame, yeah, I'm definitely liking the 17 to 35 at f4. It's looking pretty good. I will say on the 17 to 35, just a side note, a lot of people will say that this lens is disgustingly soft because for some reason this lens back focuses on every Nikon body I've ever owned. I've probably gone through a dozen of these 17 to 35 lenses, and all of them have needed a -10 to -20 AF fine tune. And I'm talking countless Nikon bodies, D4s, D800s, D810s, 600s, 750s. It doesn't matter. They all needed the same back focus adjustment for this 17 to 35. So I think a lot of people kind of have written this lens off when it just needs some AF fine tune. In live view, if you own one of these lenses, or if you know someone that has and that complains about it, just take a picture of it in live view and you'll see what I mean. It'll look sharp in live view, and then go back to using your AF sensor and there's back focus. Just a weird thing with this lens. So when you actually get it focused correctly, it's not a bad lens at all. It's really great. So with that being said, let's kind of look at some of the other corners here. Still looks like the 16 to 35, I would say they're about the same here. Maybe a slight edge to the 17 to 35 at f4. Not bad. Not bad at all. Coma is not a problem. And if I zoom out on this at f4, these are great. These look like great images. These are just JPEGs, by the way. I didn't do any processing, or we're not going for winning a Milky Way photography award here. Just wanted to point out image quality for you. So looks good at f4. So last comparison here is f5.6. So again, 17 to 35 on the left and the 16 to 35 on the right. It's pretty dark because I'm only at ISO 3200, 20 seconds, f5.6. So now we're getting kind of dark images. These are taken on a D810. There might be some noise reduction applied. So if that matters to you, just want to throw that out there. So at f5.6, I'm liking the 17 to 35. Although it looks like the 16 to 35, this particular star looks sharper, less chromatic aberration. In fact, I'd say the 16 to 35 is way better at 5.6. I'm just looking at this myself for the first time. So you can make your own judgments. This is here to just help you if you're trying to purchase one of these or thinking about which one to pack. Kind of use some of this data for helping you out. Yeah, I'm kind of leaning towards the 16 to 35 at 5.6. Not too bad. There's some aberrations in the 17 to 35 that I'm seeing here. So that's it. I don't have a whole lot else to say. I guess you could look at Jupiter, compare that. Yeah, there's some more CA on the 17 to 35. So I don't know. These lenses, I can't really say I like one or the other more. They both have uses. So I would say if you money's not an issue, just get both. But if you're looking to, if you have a need for the constant f2.8, then the decision is simple. If you are needing the stabilization, then the decision is simple there. But feel free to ask questions or leave comments below. I'm going to try to do some more of these videos. I've got quite a few other astro lenses and some other telephoto zoom lenses that I've been using on my SkyGuider Pro that I'd like to do some comparisons with for kind of budget astrophotography and some more deep sky astrophotography stuff. So feel free to, if you want to subscribe and see what else I've got here. Maybe I'll get some better equipment and make these videos better. But for now, it is what it is. Hopefully this helps you out. Take care.